All right, guys, this is what you missed yesterday. We talked about domain and range. So this is section 1.6 notes. We put this in our notebooks when you're done. We made a pocket because if you look, it's double-sided. So we made a pocket on page 18 and then tucked this in. So when you're done with this video, see if Coach has a glue stick and go ahead and put this one in. If not, just tuck it in your pocket and up front in the front of your notebook, and we'll hold on to it, and you can we can glue it in next time I see you. All right, so I'm gonna run through the vocabulary first, and then we're gonna go through some different examples. The good news is this is pretty straightforward. It's just a matter of remembering which thing you're dealing with and then knowing what your answer is gonna look like. All right, so talking about domain, which hopefully you've heard before. So domain is all the x values, and it's the independent variable. Hopefully you remember that from science. And it's also the inputs of the function. And then range is just the opposite of all of those. So your range is your y values. It's the dependent variable, and it's the output of the function. All right, so there's two different types of functions that we're going to talk about. So there's discrete and there's continuous. So discrete is a function that, well, it's easier actually to talk about continuous first. Continuous is exactly what it sounds like, the word continue. So it's something that's connected, that everything continues through. So if you see any type of graph where the points are connected, it's a continuous function. If you have an equation for it, it's a continuous function. If you've got points, then just points, so a table of values, a mapping, or just a list of points, those are discrete. So, and a discrete function is when you don't connect the dots, when you don't connect the points. So these two right below that are examples of discrete functions. All right, and like we just said, domain is x and range is y. So for this one, that's your domain. It's just those three numbers. And then this would be your range, those three numbers. When you're dealing with a mapping, remember the first bubble are your x's and the second bubble is your y's. So it's the same thing. That's your domain. And that's your range. And for discrete, it's really easy. All you do is just write those points down. So if you look over at the top of the right-hand side, they give us this example right here, and we're looking at these 4 points. And they went through and did the domain and range for us. They wrote it out. So the domain is just the x values of the points. So 0, 1, 2, 3. So that's your domain. For your range, it's the y values. So it's 2, -5, 8, and 10. But if you look, they flip-flop the -5 and the 2 because you always want to write it from smallest to largest. All right, so that's how you do domain and range. It's that pretty much that easy. So what they want us to do on this next example is look back at the mapping and then write down the domain and range for that. All right, so there we go. Slide it so you can see both. All right, so you want to use braces. That's what those are called. They're basically like a backwards 3 and a forwards 3. They're just a little squiggly. So write it, if yours is just a squiggly line, that's fine. I'm not going to get bent out of shape about it. All right, so the x values for that one are 0, 1, 3, and 9. So that's all we write down. So that's the domain. And then the range would be just the y values. So -5, 4, 8, and 14. So if you're dealing with discrete functions, they're really easy. All right, you just write down the x's and write down the y's and you move on with your life. That's all you got to do. For continuous functions, you got to do a little more work. You have to look at where the graph is. All right, so a continuous function is something that can be graphed as a smooth line or a curve. One of the things came up yesterday in class that's worth reminding y'all of is the definition of a line in art class and the definition of a line in math class are not the same thing. So in art class, a line is anything. It can be curved, it can be straight, whatever. It's just an unbroken thing. But in math, for it to be a line, it has to be straight. It has to be linear. It can't have a curve to it at all. So it's just something to kind of remember. All right, so continuous function is one that can be graphed as a smooth line or a curve. And so what that means is if we were to do the x values, it would be all of those x values in between along this line. So that means all the decimals, everything. And I don't know about y'all, but I ain't got time to write all that out. And so we use inequality symbols to kind of shorten that. All right, so real quick, I draw all over my graphs when I do domain and range. You don't have to, but I think it helps, at least for me, for visually it helps. So this is my x-axis. So I want to figure out where the smallest x is on that graph and where the largest x is right on that graph. And so everything in between those 2 points, that's my domain. All right, and then we do the same thing for the y's. I find the smallest point and then the largest point, and then everything in between those is my range. All right, I'm gonna go ahead and flip the paper, so pause it if you need to go ahead and finish copying that. All right, so on the back, it's the exact same graph over here. So we're just gonna actually do the domain and range now. All right, so when we were doing that, we said that the domain started here, and that's -7, and it ended here, and that's 4. So it's -7 is less than or equal to x, which is less than or equal to 4. And then we go and do the same thing for the y's. So my smallest y is right here, it's -3. And my largest y is up here, it's +7. So it's gonna be -3 to 7. All right, then they lead you through a little bit here. They say, all right, look at the graph to the right. What do you notice that's different? So up here, both of these endpoints were filled in. They were closed circles. But if you look down at this one's a closed circle, but this one's an open circle. Hopefully somewhere you remember about open circles when it comes to inequalities. So inequality sign, if it's an open circle, it's either less than or greater than. If it's a closed circle, then it's less than or equal to or greater than or equal to. And they've got that here, so if you need to highlight that for yourself or underline it so you know that that info's there, you've got it. All right, so we're gonna go through and do the domain and range on this one. It's the exact same thing. Doesn't matter whether it's open circle or closed circle when you're figuring out the numbers. You just gotta do it. All right, so for this one, my smallest x value is -6, and my largest x value is +6. So I've got those, and I'm gonna do -6, x, and +6. And now I'm gonna go back and look at my endpoints so I can figure out the inequality symbols. So this one is filled in, so that's gonna be less than or equal to. At 6, it's open, so that's gonna be just a regular less than. All right, and then for the range, we're gonna do the same thing. So for the range, my smallest y value is -6. My largest y value is at +4. All right, so -6, y, and 4. And then we'll go back and look at the endpoints to figure out the inequality symbols. So that's an open circle. So it's less than or equal to. The 4 is at a closed circle. Oops, I did that wrong. Sorry, y'all. -6 is at the open circle, so it's regular less than. And then 4 is at the closed circle, so that's the less than or equal to. All right. So the last thing we're going to look at is graphs that don't stop, that don't have endpoints. So all the ones we've looked at so far were line segments. But if you look up in the top right, that's a parabola. For those of you guys that took foundations before, you saw that in the fall, hopefully. So that's a parabola, and the arrows mean that it keeps going. All right, so next question, is this a discrete or continuous graph? Well, if you look at it, it's connected, so it's continuous. So that means we're gonna be using the inequality signs. All right, so this one is a little special. All right, so if I were trying to go in to draw in my ends for my domain, I can't, because those arrows are gonna keep spreading out. It's gonna keep going this way. So it's gonna keep spreading out and spreading out and spreading out. So my domain is actually everything, because it's eventually gonna spread out and hit all of the numbers. So if that's my domain, this is how I would write that. I would write it as negative infinity to positive infinity. So negative infinity is like the smallest number you could ever possibly have. Positive infinity is the biggest number you could possibly have. So you just have to write it out like that with your x in the middle. Now for the range, we can do a little bit because our at the bottom, we can't draw it because those arrows are still pointing down. So it's going to keep spreading out. So there's no low number, but there is a high number. It's not going to like magically turn around and start coming back up. It's going to keep going down forever. So we do have a top number. So the biggest y value we could have is 4. But then my range is everything in between 4 and then the smallest number we could possibly have. So that's the range. And so the way you write that is it's just a one-sided inequality. All right, so this is saying everything below 4 for our range, because it doesn't have a bottom, it doesn't have a lowest level to stop it, because it keeps going down forever. All right, hit pause for a second. Try this one, and then when you're ready, unpause, and I'll go through it with you. No, seriously, pause it. Pause it, don't cheat. All right, so the domain, we start here. So our smallest x value is at -6. Our largest x value is at 7. So -6, x, and 7. All right, the -6 is at an open circle, so it's less than. The 7 is at a closed circle, so it's less than or equal to. All right, then for the y values, our smallest one is 2. And our largest y value is at 8. All right, 2 has the closed circle, so it's less than or equal to. 8 has the open circle, so it's regular less than. All right, so fold this in half, put it in your notebook on page 18, make a pocket like we made for the quizzes or we put at the front of our notebook, and then fold this in half and tuck it in the pocket. And then again, this is your section 1.6 notes. I'm gonna send you guys the practice that we're gonna do in class, and then the homework assignment. So the homework says homework on it. The half sheet of paper is the practice. So the practice is gonna go in your notebook on page 19. And then the homework, give to coach or bring to class. Actually, go ahead and turn it into coach, because I'm not gonna see you guys for a couple of days. And then we'll go from there. All right, thanks y'all, bye.